This is one of the most mysterious and controversial objects in the world.
Mainstream scientists argue they are all modern creations.
They sit in museums behind glass, their hollow eyes staring back at visitors with unnerving stillness. Crystal skulls carved from solid quartz, impossibly smooth and disturbingly lifelike.
Any analysis of the skulls is incomplete, as quartz crystal cannot be carbon dated.
Quartz has no carbon. Quartz actually has no radioactive elements in it. It gets almost impossible to actually date it.
For more than a century, archaeologists, scientists, and historians have debated where they came from, who made them, and why. Now, cutting-edge DNA analysis and biomolecular testing are beginning to paint a picture that no one anticipated. The truth might be stranger than the legends themselves: the emergence of the crystal skulls. The first crystal skulls appeared in public collections during the late 1800s and early 1900s, a time when European and American museums were hungry for exotic artifacts from distant lands. Central America and Mexico became hotspots for archaeological curiosity, especially as ruins of Maya and Aztec civilizations were being uncovered and explored. Amid this fever for ancient treasure, crystal skulls began surfacing in the hands of collectors, antiquities dealers, and adventurers. Most of these skulls were said to originate from regions tied to ancient Mesoamerican cultures. The stories varied wildly. Some claimed they were pulled from buried temples. Others said they were found in the possession of indigenous shamans or hidden in remote jungle caves. What united these objects was their mysterious craftsmanship and the fact that no one could agree on when or how they were made. The skulls captured public imagination immediately. They seemed to represent something beyond ordinary artifacts. Were they religious objects, tools of divination, symbols of power? The fact that they were carved from rock crystal, one of the hardest natural materials on Earth, only deepened the intrigue. How could ancient people, supposedly lacking advanced metal tools, carve something so intricate and flawless? The questions multiplied faster than the answers. The most famous crystal skulls in history. Among all the crystal skulls that have surfaced, a handful have achieved legendary status. Each has its own story, its own peculiarities, and its own mysteries. The Mitchell-Hedges skull is perhaps the most famous. It was reportedly discovered in 1924 by Anna Mitchell-Hedges, the adopted daughter of British explorer Frederick Mitchell-Hedges, inside the ruins of a Maya temple in Belize. The skull is carved from a single block of clear quartz and features a detachable jawbone, something that adds to its eerie realism. Anna claimed the skull was a sacred object used by Maya priests. Frederick Mitchell-Hedges himself described it as being at least 3,600 years old, though he offered little proof. Skeptics later suggested it might have been purchased at auction, but the ambiguity only fueled the legend. The British Museum skull was acquired in 1897 from a Mexican antiquities dealer. Smaller than the Mitchell-Hedges version, it's carved from cloudy quartz and lacks the moving jaw. For years, it was believed to be a genuine pre-Columbian artifact. However, microscopic analysis in the 1990s revealed tool marks consistent with modern rotary equipment, suggesting it was likely made in the 19th century. Still, questions remain about the materials used and whether older traditions influenced its creation. The Smithsonian skull came from Mexico and is made from smoky quartz. It was donated to the museum anonymously in 1992, with a note claiming it had been purchased in Mexico in 1960. Unlike some of the more dramatic examples, this skull is simpler in design but no less puzzling in origin. The Paris skull resides in the Musée du Quai Branly. It's smaller and less detailed, but like the others, its exact history is murky. Some records suggest it came from an Aztec source, though no definitive evidence ties it to any verified archaeological site. These skulls share common traits: precise symmetry, smooth surfaces, and an air of the unknown. Despite their differences, they all raise the same question: who made them and why? The impossible craftsmanship. Here's where things get technically fascinating. Quartz ranks 7 on the Mohs hardness scale, making it tougher than steel and nearly as hard as diamond. Carving it requires tools that can withstand extreme pressure and friction. Modern jewelers use diamond-tipped rotary tools and ultrasonic drills to shape quartz. Even with these technologies, the process is slow, difficult, and prone to errors. A single miscalculation can cause the crystal to fracture along its natural cleavage planes, ruining hours of work. Yet some of these skulls show no visible tool marks, no scratches, no rough patches, no evidence of the grinding or sawing that would be expected from hand tools or even early mechanical devices. The surfaces are polished to near optical perfection. Light passes through the clearer skulls in ways that create internal reflections and refractions. Some skulls have concave eye sockets that act like lenses, focusing light into the interior. The Mitchell-Hedges skull in particular has been noted for its optical properties, with beams of light bending and splitting inside the crystal in ways that seem almost deliberate. Then there's the issue of the jawbone. Carving a separate, movable jaw from the same block of quartz without breaking either piece requires not just skill, but an understanding of the crystal's internal structure. Quartz is not uniform. It has invisible stress points and grain directions. One wrong tap and the whole thing shatters. How did the makers, if they were working thousands of years ago, accomplish this without advanced imaging tools or precision instruments? Some researchers have theorized that ancient artisans used a combination of sand abrasion, water, and patience, slowly grinding the crystal over years or even decades. But this explanation struggles to account for the level of detail and the lack of visible abrasion marks. It's a puzzle that even modern craftsmen can't fully replicate. Ancient legends and sacred meanings. Indigenous traditions in Central America have long held that skulls are more than symbols of death. They represent transformation, gateways between worlds, and vessels for ancestral knowledge. In many Mesoamerican cultures, the skull was seen as the seat of consciousness, the part of the body that held memory and identity even after death. Some oral histories speak of crystal skulls as sacred objects created by the gods or by ancient priests with divine knowledge. According to certain legends, there were originally 13 skulls, each holding a piece of cosmic wisdom. When all 13 were brought together, they would reveal secrets about the origin of humanity, the structure of the universe, or warnings about future catastrophes. These stories have been passed down through generations, though their origins are difficult to trace. Shamans and spiritual practitioners in some communities believe the skulls act as record keepers, storing information in ways that transcend written language. Some claim that the crystal itself can hold vibrational energy or encode data at a molecular level, a concept that blends mysticism with speculative ideas about crystalline structures and memory. While mainstream science hasn't validated these claims, the persistence of such beliefs speaks to the deep cultural significance these objects hold. There are also stories linking the skulls to astronomical knowledge. The Maya were exceptional astronomers, tracking planetary cycles and solar eclipses with remarkable precision. Could the skulls have been used as teaching tools, their optical properties employed to demonstrate celestial phenomena? It's speculative, but not entirely out of the question. How modern science approaches ancient artifacts. Archaeology has evolved far beyond shovels and brushes. Today's researchers use an arsenal of scientific techniques to extract information from objects without damaging them. When it comes to the crystal skulls, these methods have opened new lines of inquiry. One approach is surface residue analysis. Even objects as hard and non-porous as quartz can trap microscopic particles in tiny fissures, scratches, or imperfections. Using high-resolution microscopy and chemical analysis, scientists can identify organic residues, pollen grains, plant fibers, or even traces of human DNA. This can reveal how an object was used, where it was stored, and who handled it. Trace DNA analysis is particularly powerful. Human skin cells, sweat, and oils can leave genetic material on surfaces. If a skull was used in rituals, touched repeatedly, or stored in a specific environment, those interactions leave behind molecular fingerprints. DNA sequencing can sometimes identify the geographic origin of plant material or animal products that came into contact with the object. Soil DNA, also called sedimentary DNA, is another tool. If a skull was buried or stored underground, microorganisms, pollen, and organic matter from the surrounding soil can become embedded in microscopic crevices. By analyzing this environmental DNA, researchers can estimate where the object was kept and for how long. Pollen analysis is especially useful for dating and localization. Different plants produce pollen at different times and in different regions. If ancient pollen is found on an artifact, it can provide clues about the environment and time period in which the object existed. Protein and lipid signatures offer additional data. Organic materials like blood, resins, waxes, and oils leave chemical traces that persist for centuries. Mass spectrometry and other analytical techniques can identify these compounds, revealing whether an object was used in ceremonies, anointed with sacred substances, or exposed to specific biological materials. These methods are non-invasive and incredibly precise. They allow scientists to study artifacts without cutting into them or altering their structure. For the crystal skulls, this means we can finally start asking questions that go beyond who made this and begin exploring what was this used for. The quartz didn't come from where we thought. One of the most startling revelations to emerge from recent studies involves the origin of the quartz itself. For years, it was assumed that if the skulls were genuinely pre-Columbian, the crystal would have come from Central American sources. Quartz deposits exist in Mexico, Guatemala, and Belize, so it made sense that local artisans would use local materials. But chemical analysis tells a different story. Quartz isn't all the same. Trace elements, isotopic signatures, and mineral inclusions vary depending on where the crystal formed. By comparing the chemical composition of a skull's quartz to known geological deposits, researchers can pinpoint its likely origin. Some skulls have been found to contain quartz that matches deposits in Brazil, thousands of miles south of the supposed Maya heartland. Others show signatures consistent with Madagascar or even regions in the Himalayas. This doesn't necessarily mean the skulls are fake or modern. Instead, it raises a far more intriguing possibility. What if ancient trade networks were far more extensive than historians believed? The idea of a prehistoric global trade system sounds far-fetched, but evidence is mounting. Obsidian from Central America has been found in North American sites hundreds of miles away. Jade from Guatemala appears in distant Olmec and Zapotec contexts. Copper from the Great Lakes region made its way into the hands of Mississippian culture builders. If cultures were trading valuable stones across vast distances 3,000 years ago, why not quartz? Another possibility is that the skulls were carved elsewhere and brought to Mesoamerica as trade goods or diplomatic gifts. The Maya and Aztecs valued exotic materials. Turquoise, jade, and feathers from distant lands were symbols of power and divine favor. A crystal skull made from Brazilian quartz could have been seen as an object of immense spiritual and political importance. This finding doesn't answer all the questions, but it shifts the narrative. The skulls may not be products of a single culture or region. They could represent a confluence of knowledge, materials, and traditions from across continents. Organic evidence tells a different story. When scientists examined the surfaces of some skulls under high magnification, they found more than just quartz. Microscopic wear patterns suggested repeated handling over long periods. The type of polishing, the distribution of micro-scratches, and the presence of organic residues all pointed to use, not just creation. Traces of copal incense were detected on one skull. Copal is a resin burned in Mesoamerican rituals for centuries. It was used by the Maya, Aztec, and other cultures to communicate with gods, purify spaces, and honor ancestors. Finding copal residue on a crystal skull suggests it was part of ceremonial life. Blood residues have also been identified. While degraded and difficult to analyze, the presence of hemoglobin breakdown products indicates that the skulls may have been present during sacrificial rites or bloodletting ceremonies. Both were common in Mesoamerican religion, where offering one's blood was seen as a way to nourish the gods and maintain cosmic balance. Ancient pigments, likely from body paint or decorative applications, were found in microscopic crevices. Red ochre and black carbon, both used in ritual contexts, appeared on multiple skulls. These pigments don't come from modern handling. Their chemical composition and degradation patterns match those found in pre-Columbian archaeological sites. Burial dust is another clue. Some skulls carried particles consistent with cave sediments found in Maya ceremonial sites. These caves were often used as burial chambers or places of pilgrimage. If a skull spent time in such an environment, it would pick up the unique microbial and mineral signature of that location. All of this suggests that even if some skulls were made more recently than claimed, they were used in ways consistent with ancient traditions. They weren't just decorative objects, they were active participants in ritual life, dating the undateable through environmental clues. Quartz itself can't be carbon dated, it's not organic, and it doesn't decay in predictable ways. But the materials trapped on or inside a skull can be dated. Pollen, plant fibers, and organic residues all contain carbon, and carbon-14 dating can estimate their age. In some cases, pollen grains found on skulls have been traced to plant species that thrived in Central America during specific historical periods. If the pollen dates to 3,000 years ago, it suggests the skull was present in that environment during that time. It doesn't prove the skull was carved then, but it places the object in a context that predates European contact. Soil DNA offers another timeline. Microorganisms and plant DNA embedded in sediment have their own evolutionary and ecological markers. By comparing ancient DNA from a skull's surface to modern environmental samples, researchers can estimate how long the object was buried or stored in a particular location. These methods aren't perfect. Contamination is always a risk. Modern handling, museum storage, and even cleaning can introduce new organic material. But when multiple lines of evidence converge, a clearer picture emerges. Some skulls show organic markers that align with ancient rather than modern contexts. This doesn't confirm a 3,000-year-old origin for the carving itself, but it does suggest prolonged use in pre-Columbian settings. The mystery no one can solve. Even with all these scientific tools, some aspects of the crystal skulls remain unexplained. The polishing technique is the biggest enigma. Achieving optical-grade smoothness on quartz without modern equipment is extraordinarily difficult. Some researchers have attempted to replicate the process using ancient methods, stone tools, sand abrasion, and plant-based polishing compounds. The results are promising but never quite match the perfection seen in the original skulls. Tool marks or the lack thereof are another puzzle. Some skulls show faint traces of rotary tool use, suggesting modern manufacture. Others show none. If they were made with primitive tools, why aren't there more signs of abrasion? If they were made with advanced tools, where did those tools come from? The optical effects are perhaps the most unsettling. Light doesn't just pass through the Mitchell-Hedges skull. It bends, refracts, and creates internal patterns that seem intentional. Some observers have reported seeing images or shapes inside the crystal when light is shone through it at certain angles. Whether this is a deliberate design feature or a natural consequence of the crystal's structure is unclear, and then there's the question of motivation. Why carve a skull? Why use quartz, one of the hardest materials available? Why invest what could have been years of labor into a single object? If these were religious artifacts, what rituals did they serve? If they were symbols of power, who wielded them? We still don't know. The crystal skulls sit at the intersection of art, religion, trade, and technology. They challenge our assumptions about what ancient people could or couldn't do. They remind us that history is not a straight line and that knowledge can be lost as easily as it's gained. The skulls may never give up all their secrets, but every new test brings us closer to understanding the people who valued them, even if we never fully understand how they were made.